Thank you very much. So good morning. I'm going to show you the results of some work carried out in collaboration between the University of Zaragoza, where I am a lecturer, and Epic Power, which is a company, it's a spin-off of the University of Zaragoza, and is specialized in power electronic devices for lift applications. Let's find the micro. Okay. So first of all, I'm going to show this the overview of what I am going to talk about. First, I will show you what standard lift drive is. Next, why sometimes we need energy storage. Later on, I will focus in the requirements of this energy storage in terms of power and energy. Once we have the requirements and we know which are the available technology, we can try to match both them, the technology and the requirements. And finally, we will see how we can integrate 48 volts energy storage system into a conventional lift. So I think that most of you know, but anyway, this is a standard drive. The energy source is a fixed voltage, fixed frequency, three-phase main. First, this energy is converted to a DC voltage boost, and later on, thanks to a three-phase inverter, we get variable voltage and variable frequency. Thus, we can feed a permanent magnet synchronous machine, and we can get the required motion in the lift. Why energy storage? Basically, we need energy storage when we need additional functionalities. I am going to give you 4 examples. First, this is quite evident, an interrumptible power source, power system. So sometimes we need an extended UPS, so we can carry out as much as 100 travels in the case of a line blackout. For doing so, we need some kind of energy storage system, battery or something like that, which is connected to the high voltage DC boost of the standard drive. Another example, we can talk about an energy recovery system. It's a system which is able to store the energy which comes from the lift when it is the lift is generating, and later on, this energy will come back to the lift when the lift is absorbing energy. Another example, sometimes we need to mitigate the peak consumption. Sometimes we are not able to provide 5, 6, 7 kilowatts, and in this case we can use a battery-based system which is able to provide almost any power, but this battery system is fed by a single phase low power connection. So it's another example, and of course, once we have a battery system, we can talk about a lot of additional functionalities, and we can connect any energy source, solar, wind source, the power line, single, and so on. So we can build different puzzles with different elements. Which are the required energy or power requirements on lift, of common lifts? I am going to show you 2 graphs. On the left, we have the energy requirements. On the right, we have the power requirements. Energy, we can talk about small lifts and large lifts, okay? So, of course, the larger the lift, the bigger the energy we need. I'm showing you quite a standard trips. We are talking about five floors, and I am showing 2 different cases. The first case, the green one, is when we need a big amount of energy. I'm talking about a UPS, extended UPS functionality with as much as 100 travels. or trips. And in the other hand, we have very small energy capabilities, which are enough in order to fulfill energy recovery system requirements. In the other hand, if we take a look to the power, we have small powers, 3.5 kilowatts, more or less, with small lifts, and we can have as much as 11 or more kilowatts, depending on the lift. So these one are the requirements. What the technology is offering? First of all, we must focus in mature, well-known technologies. If we are thinking about something that can be accepted by customers. So we have batteries and ultracapacitors. There are a lot of different types of batteries. The very well-known ones are lead-acid batteries, are not the best, are the worst, but are the cheapest, well-known, are very easy to install, and they have not complex battery management systems. So basically, we need a big amount of energy is the preferred choice by the industry. Lithium batteries normally are used if you have some weight or volume limitations, which is not the case. On the other hand, if we are dealing with a lot of charging, discharging cycles in energy recovery system functionality, we must think about ultracapacitors because they are offering a lot amount of cycles. So how can we match technology and requirements? First of all, we must take a look what is a standard battery or standard ultracapacitors. And everybody knows that the standard nominal voltage, the highest standard nominal voltage of batteries is 48 volts. It's the same for ultracapacitors. What do I mean with a standard voltage? I'm talking about the availability of a lot of elements that are needed when you work with battery commercial battery chargers, battery management systems, and so on. So here we have something like a summary. This is, here you have the power requirements and the storage requirements, the energy storage requirements. These ones are the same curves as the previous slides, but are both then in the same slide, in the same curve. We have the energy recovery system functionality. We have here, you have the UPS functionality. If we use standard batteries, we can use 4 12-volt standard batteries, build a 84 volts module, which is able to solve the requirements of a small lift. Okay, this is the energy and power requirements of a small lift, so it's okay, it's fine. We are using only 22 liters of volume, and we can talk about a basic battery module. If we are dealing with energy recovery system application, we have the same for ultracapacitors, and with only 10 liters, we can build a basic ultracapacitor module, which is solving the problem for this application, these requirements. The fact is that using 1, 2, 3, or 4 basic storage modules of batteries or ultracapacitors, we can solve the energy and power requirements of a broad range of lifts, ranging from small to up to 1,500 kilograms. So finally, it's quite evident that a good solution could be to exploit, to focus in basic building blocks and to parallel these blocks if we must adapt them to bigger or smaller lifts. So the problem is that we are dealing with 48 volts, and the industrial and well-known technology is based on 500 to 800 volts DC boost voltage. So we have two approaches, two solutions. First, we can build a DC-DC converter connecting both systems, or another solution is just to reducing all the drive with a very low voltage technology. The first solution, here you have, this is our standard elements, and we need a non-standard elements, which is a DC-DC converter with a lot of requirements in terms of dynamic, volts, range of voltage variation, and so on. And this is the key functionalities with plug-and-play functionality and flexible. It must admit parallel connection. Why? If we are able of connecting them to any new or existing lift, to any power, we are talking about an add-on concept, which is enabling high manufacturing volume and flexible timing and flexible investment. What I mean with flexible investment is that the seller can forecast to install this device not at the beginning of the first installation, but later on, 1 year later or several months later. So it's much easier for the customer. If we get high manufacturing volume, flexible timing, and flexible investment, we get competitive cost and quite easy implantation. On the other hand, we can try to redesign the entire traction system under the new voltage. Basically, if we have only 84 volts here, we are dealing with a very, very low voltage level. So if we keep the power, we have a very high currents, and we go straight to very poor efficiencies. The advantage is that it's simpler, of course, but on the other hand, the seller have a more complex portfolio, because this is not a complementary technology, but it's a supplementary technology. So the challenge is to get a DC-DC converter with high control dynamics, the plug-and-play functionality, variable input and output voltage, and very large input to output voltage relation. The solution is something like that. This is power electronics. I am not going to bore you. But basically, if we need to move from DC to DC with a between very different voltage levels, we are forced to include an AC stage with a transformer. So the conclusions is that there are more and more functionalities that require energy storage on lifts. That lift drives the common, the industrial, the well-known lifts operates at high voltage levels, and the storage devices are low voltage levels. So we need a non-standard DC-DC converter with special functionalities. Some basic building blocks help us to organize the products and to have a clear portfolio. And up to date, as far as we know, Epic Power is the only one which is offering something like that. And that's all. Thank you very much.